So just a couple of very quick announcements that I want to make. Number one, I sent the class an email yesterday afternoon, and you need to check that email, please, at some point. Okay. So essentially, the long and short of what that email had is all of your upcoming due dates for various items. We have finished lesson 12. My plan today is to go through a couple more examples in lesson 13, and that'll call that one a wrap. Okay. Additionally, what I want to point out to everybody is that we don't have class on Friday, but as the email indicated, I have made a video of me teaching lesson 14. And in addition to the video, I have notes that are also posted to the box folder. So if you go to our class box folder, you'll see the video and notes. But in the email, I also have direct links to those. It probably will ask you to download the thing, but anyway, they should be available to you. Okay, so last but not least, on the class Moodle page, which I'm sharing with you right now, you should be able to see class activities, and worksheet 7 and 8 is now available. Okay, so this worksheet is for lessons 12 and 13, and will be very good practice for you. My email that I sent yesterday has all of the due dates, so please check out that email in order to get the due dates. Okay, are there any questions about that sort of practical stuff? So 10 o'clock on Friday morning, you're welcome to watch the video. It's not even a full 50 minutes. It's not a huge section. Lesson 14 is not. But we're not having class at that time. Okay. So before I jump in and talk about the things I want to talk about and answer any questions about homework, does anyone have any questions about what the rest of the week is going to look like? Other than probably some more snow, which is exciting to me. All right, well, cool. So just, I think what I would like to start out doing is just working through a couple of examples in lesson 13. And then what I'd like to do for the rest of the class is answer any questions anybody might have over lesson 12. I will also add that while I will not be here in Missoula for the rest of the week, I will have access to email. So of course, if you're working on the homework and have any questions, hit message instructor. I assure you, I will have time to get back to you. I'm in a 2-day long meeting. Literally, it starts at 7:15 in the morning and goes until 5 in the evening. Trust me, I've got some time to check my email. So anyhow, does that all sound good to you guys? Cool. Cool. All right. So yesterday we were talking about revenue because we want to make money. We were talking about costs because that's the way life works. We have costs. And then finally, we talked about the profit, which we saw that profit is our revenue function minus our cost function. Okay. So what I want to do right now is just take us through a couple of examples so you get a taste of some more details of this particular section. So yesterday, you may recall, we talked a lot about the cost function and we looked at all these different scenarios of finding our cost function. Then we also talked about our revenue function. Okay. So my first example is as follows. It's kind of a funny one in the sense, well, I'll tell you in a second. Producing X units of tacos. I don't know what a unit of tacos is, right? Like, isn't that kind of a funky term? But producing X units of tacos costs 5X plus 20. Notice in this case, we actually have our cost function and produces revenues of 15X. Okay. So in this case, this is almost about as nice as it can get. You're given your cost function and you're given your revenue function. Just to tie in what we were talking about yesterday, remember with our cost function, this 20, those are our fixed costs. And this 5, that's the cost to produce each unit of tacos. Okay. And then in terms of the revenue, what this 15 tells us is that we charge $15 per unit of tacos that we sell. There better be a lot of tacos if they're 15 bucks. Okay. So part A, what we first want to do is find our profit function. Okay. Well, again, we have the formula that the profit is equal to your revenue function minus your cost function, right? Take all the money you make, subtract off all your expenditures, and fingers crossed for a positive number, right? Okay, so let's do that. Our profit function, literally, you take your revenue function, and then you're going to subtract off your cost function. You got to be sure you subtract off your entire cost function. And what does that mean? It means you need parentheses around your entire cost function. Okay. That's really important. Now what we're going to do is simplify our right-hand side, which means we're going to distribute this negative sign throughout our parentheses. If I do that, I have 15X, well, then minus 5X, and then minus 20, right? Because -1 times 5 is -5, -1 times 20 is -20. It's crucial that you remember your parentheses because otherwise you're going to be keeping a plus sign next to the 20, and that's just going to lead to some really funky things. All right, we can now combine like terms. 15X minus 5X is 10X minus 20. So that's my profit function. Again, I tend to write my variable on my left side. You don't have to if it messes with you. Questions on finding the profit function? Both of these were given to us. Oh, okay. Yes. All right. What if now we want to find our break-even point? I defined that for us yesterday. When you find the break-even point, what that says is you want to find the value of X. In other words, we want to find the number of units of tacos so that our profit is 0. We don't gain anything, but we don't lose anything. Well, can we do that? Yeah, we have our profit function. We want to find the number of units of tacos so that this is 0. So we say 0 equals 10X minus 20. Can I solve this? One hopes. What would I do first? Add 20 to both sides. So I have 20 is equal to 10x, and now divide both sides by 10, and we're going to get x equal to 2. So if we produce and sell 2 units of tacos, we are going to break even. You okay so far? All right. Well, let's just play around with this a little bit more, and then we're going to get to a little bit more of an involved example. And when I say a little bit more of an involved example, it means you're not going to be given your cost and your revenue function. Okay. But what if I ask you, oops, this is part C. How many units of tacos do I need to produce and sell in order to realize that I should go into a new business? Maybe. Anyway, in order to realize a profit of, say, $500. How would I do this? Well, again, we have 2 unknowns. We have the number of units of tacos and we have the profit. Okay, what are we looking for here? The units of tacos. I'm looking for my X value. So I better be given something for my profit. And am I? Yeah, what is it? 500. So instead of solving this profit to be equal to 0 in our last example, we now want to make some cash. Well, we can solve this in much the same way. First step to getting X alone is to add 20 to both sides. And now we divide both sides by 10. And so we need to produce and sell 52 units of tacos. You with me? All right, one more just to be sure we're comfortable playing with these things. Suppose I tell you, hey, I produced and sold 12 units. Oops. Let's say 15. Let's make a little bit more money off of that. 15 units of tacos. What was my profit? Again, we have our profit function to be equal to 10x minus 20. Notice we have 2 unknowns. What are we looking for here? We're looking for our profit. Therefore, we better be given our X value. Are we given our X value? Sure we are. We plug in X equals 15. And now I get 150 minus 20. So I'm going to make a whopping $130. All right. Questions on this? Okay, I have one more example to do from this section. Suppose I produce and sell t-shirts. Okay, this is going to be the most involved question that we have. Okay, I'm going to tell you that the cost to produce, 60 t-shirts is $300. And the cost to produce 78 t-shirts is $363. I sell these t-shirts for $9 a piece. What a screaming deal, huh? $9 for a t-shirt? Deal. So what I want us to do here is find the cost function. Then find the revenue function. Then find the profit function. And finally, we will find the break-even quantity. All right, now what's difficult about this is the fact that we're given a bunch of numbers and you need to put the numbers in the appropriate places and figure out what they pertain to. Because some of these numbers are going to be relevant for us finding our cost function. Some of these numbers, or one of these numbers, is going to be relevant for us to find our revenue function. Okay, and then once we have our cost function and our revenue function, we will then be able to find our profit function. Okay, stop me if you have any questions. And again, as I mentioned yesterday, the cost function is the most involved to find. All right, well, let's start with it then. Okay. We're given a bunch of information up here. And one thing says is that we have 60 t-shirts costing $300 to make and 78 t-shirts costing us $363 to make. Those are both relevant for our cost function. Remember, our cost function is MX plus B. So in order to find the cost function, we need to find M and we need to find B. Okay, notice we are not given either one of those directly, right? If I was given B, I would be telling you what my fixed costs were. I don't give you that. If I gave you M, I would be telling you what the cost to produce each t-shirt is. And I don't give that to you either. So you might be like, well, how do I find this equation? Totally reasonable question. Well, I claim we have two ordered pairs. And when we have two ordered pairs, can't we find the equation of a line? Yeah. One ordered pair is that when I make 60 t-shirts, it costs $300. The other one is when I make 78 t-shirts, it costs $363. This is about as involved as these problems can get. So I figure if I do the worst of them, then we're cool. Or hopefully. All right, I have two ordered pairs. What's my first step to find the equation of a line? Lesson 12, friends. What's the first thing we do? Good, we find our slope. Awesome. Okay. And this brings us back to lesson 12. Remember, our slope is the change in Y values divided by the change in X values. I intentionally made these numbers pretty nice. So I have 63 over 18, which gives us 3.5. We have now found our marginal cost, AKA variable cost, AKA cost to produce each t-shirt. It only costs us $3.50. Okay, but we've now found our slope. We now have that C equals 3.5. And if you want to make it in terms of dollars and cents, you can attach a zero. You don't have to. Plus B. We now need to find B. Well, how do we find B? Good. We take one of these ordered pairs and plug it in for our X and our C, and then we find B. Doesn't matter which ordered pair. I usually take the one that looks like it involves the least amount of computations. Okay, so I'm going to take this one. You'll get the same thing if you take this ordered pair. So we know that our cost is 300 when we make 60 t-shirts. Well, if I take 3.5 times 60, I get 210 plus B. And how do I solve for B? Subtract 210 from both sides, and I'm going to get B to be 90. So my cost function is 3.5x plus 90. Stop. We are done with finding our cost function. Before I move on, are there any questions as to how I proceeded? Okay. Well, from here on out, I claim it's a little less involved. Okay. How do I find my revenue function? Well, recall we talked about our revenue function yesterday. Our revenue is the selling price per item times the number of items sold. How much are we selling these t-shirts for? $9. So can someone tell me what the equation for my revenue function is? $9x. Good. Good. I know that sometimes it's like, you're waiting for something to be really, really, really hard. Okay. Your revenue function is straightforward because literally the amount of money we make is the number of t-shirts we sell times our selling price per t-shirt. All right. My next step is to find my profit function. Well, our profit is our revenue minus our cost. Notice we found our revenue function and we found our cost function. So in the previous example that I did with the tacos, this was kind of our starting point, right? We were given both of these. Well, my revenue function is 9x. My cost function, don't forget your parentheses, is 3.5x plus 90. And again, we need these parentheses because I need to distribute my negative sign throughout. Again, I'm subtracting my entire cost function, not just the first term. So I have 9x minus 3.5x minus 90. Well, 9x minus 3.5x is 5.5x minus 90. And that's my profit function. Now on a test, if you got either one of your cost or your revenue functions wrong, but then found your profit function correctly using those wrong ones, I obviously would not take off points here. All right, last but not least, we were asked to find the break-even quantity. Again, you can look at that two ways. Since we already found our profit function, I would just set our profit function equal to 0. Another way you could do it, which is absolutely equivalent, is we know that we have 0 profit when our revenue is equal to our cost. Either way. But since we already found our profit function, we might as well, yippee, use it. You with me this far? So I take my profit function and set it equal to 0. First step, add 90 to both sides. Next step, divide both sides by 5.5. And we're going to get X to be 16.36, blah, blah, blah. We talked about the rounding business yesterday. Okay, again, in the context of word problems, you don't use the rules of rounding. You got to use it in the context of the question. Okay, so I claim 16 and a little over a third t-shirt is going to do it for us. Are 16 t-shirts enough? Okay, we need to produce and sell 17 t-shirts to break even. What do y'all think? All right, so what I want to say to everybody is I am going to share my screen here. All right, so here's our My Open Math page. How very exciting. I believe I already set the due dates. So in Unit 4, we did lesson 12. I just want to point out that lesson 12 is due next Monday by midnight. We have now finished lesson 13. And today's Wednesday, not Tuesday. So what I'm going to do is I'm going to change this due date to be a week from today. I apologize. I made it a week from yesterday originally. That was my mistake. So lesson 13, we just completed. That's due a week from today. You dig so far? All right. Lesson 14. That's the video that I made that I sent to you that's already linked in the email, you know, to the box folder. And that's going to be due, I have it due way later. I gave you a lot of time for that. So you have plenty of time to do this. In the video that I made for you yesterday, I talked about what's expected and what you need to know from lesson 14. I also, on top of that, of course, did examples. But on top of that, I did guide you through the online homework. I think there's only 5 questions in the online homework for this section. And I guided you through pretty much how to do every single one of them. Okay. So what I want to mention is with our lesson 13 online homework, the section we just finished today, just to give you an idea of what to expect, because I like talking you through these homeworks. My hope is that it actually helps you when you're working on each particular exercise. Okay, this first one is not a cost, revenue, profit. It is simply a word problem, okay? So what I want to mention to you to get you going with these things is as follows. Again, your numbers are going to look slightly different than mine, but now we're talking about the growth of a moose population. Notice they want T to stand for the number of years since 1990. We did an example like this the other day. So if we want to find a formula for the moose population, I claim in this first one, you're given 2 ordered pairs. Okay, the first ordered pair tells us what the population was in 1992. As an ordered pair, I would say that's 2, in my case, 3720. Why is it 2? Because 1992 is 2 years after 1990. Does that make sense? Right? They tell you how they want your T to be defined. So in 1996, tell me, using my numbers here, what would be my corresponding ordered pair? 6, 4240. And then from there, they want you to find the equation of the line. Again, first find your slope, then plug in one of these ordered pairs to find your intercept. And then they just want you to use that to make a computation. Questions on the first one? All righty. Yeah. That's an awesome question. Thank you for asking that. So the question was to do this second part. If we want to predict the moose population in the year 2005, what would we plug in for T? We would plug in T equals 15 because 2005 is 15 years after 1990. Thank you for asking. You're awesome. The rest of the class is thanking you as well. Trust me. You okay? Cool. All right. The next exercise that you are asked to do is another linear equation. Okay. Now, what we're told here, at least using my numbers, is that currently we have 2,160 barrels of oil, or billion barrels. Thank goodness for the billion. If on average, the total reserves is decreasing by 18 barrels per year, I claim we can find our equation just straight from these numbers. Okay, how would we do that? Well, I don't even have to annotate that. How would we do that? Well, what is our y-intercept? 2160, right? That is our current value. And what's our slope? -18. So as you see, literally, you're given your slope and your y-intercept. This is an exercise to be sure that you know how to interpret that. And then from there, what they want you to do is, in this part, you would plug in T equals 7. And then here, we want to know when our reserves are 0. So you would set this guy equal to 0. You with me here? All right. Next ones are cost, revenue, profit. Here we go. In this first one, you're given your marginal cost and your fixed cost. So you're given essentially your cost function. I think the thing that'll mess most people up here is notice they want you to use the variable N. Okay, so literally they were $1.63 a piece to make, and we had $230 for our fixed costs. We're also given the revenue. We're selling them for $2.89 a piece, etc. So do you see how this one's a pretty direct one? In this next one, this is like the first example I did today. You're given your cost, you're given your revenue, and they want you to find your profit function and the break-even quantity. Here, you're given the equation. The red one is going to be your cost function. Your blue one is going to be your revenue function, and they want you to find the break-even point. Literally, remember, it's when your cost is equal to your revenue. So it's where your two lines intersect. And then they want to know what your fixed costs are. And again, that's identifying, my fixed costs are my y-intercept of my cost function. Here, you're given, again, your variable cost and fixed costs. You're given your selling price. And so again, this is very similar to what we just did. And then here, it's just computing slope. Okay. So that guides you through the lesson 13 homework. Again, don't forget that on the Moodle page, we have this worksheet 7 and 8, and actually I'm going to bring that up. Those of you on, well, I'm just not even going to ask. Oopsie. Let me go here just to show you this worksheet that you have. I'll bring printed copies on Monday, but notice, find the slope of the line containing 2 points, find the equation of the line, find your x and y intercepts. Okay, this is lesson 12. Here you're given an equation. What's the niftiest way to find the slope and y-intercept when you have an equation in this form? Good, solve it for y. You can just read right off your slope and your y-intercept. And then this asks you to find an equation of a line parallel to it. What do we know about parallel lines? Same slope, beautiful. Here you have a line and you want to find the equation of a line perpendicular to this, but with the same y-intercept. So again, you're going to want to solve this for y. Okay. And then finally, here's a line passing through these ordered pairs. Find the equation if it's vertical, if it's horizontal, and if it has that particular slope. Your test will not contain nearly this many formulaic sorts of questions, but I want you to get the practice. And then finally, this is a cost, revenue, profit, break even. Okay, so this is what your next worksheet consists of. It's not due until after Thanksgiving. We can talk about it next week for sure. All right. So the next thing that I would like to know is, do you have any questions for me? We have 10 minutes where I can go through anything that you need me to. Yeah?
And or the very last one was not exist.
When your slope, okay, so this pertains to question number 4 in your online homework, and everyone's going to have some variation of this. When it says that your slope does not exist, we use DNE for does not exist. That means you have a vertical line. So a key thing to remember is as follows. The equation of any vertical line passing through some general ordered pair is always just x equals whatever the x value is. So whatever ordered pair you're given, just nab your x value and there you got it. Okay. Now, similarly, if they tell you that the slope is 0, what kind of line do we have? We have a horizontal line. And what we also saw is that the equation of any horizontal line passing through a point is always y equals whatever the y value is. So when you have a slope equal to 0, you just take y equals whatever that random y value was. Whenever you have a slope that's undefined, that's a vertical line, that's totally free fall. Sounds pretty scary to me. And it's always x equals the x value. That does appear on your worksheet in your online homework. I'm not going to ask you horizontal and vertical on your test, but that's beside the point. Other questions? Yeah?
Pretty much 9.
Oh my gosh, isn't that so great? Someone else asked me to do number 9 too. Okay, so what I need to do is jump to that. Okay, I'm going to share my screen. Number 9. Doink, doink, doink. Okay, come on. So lesson 12. Number 9. Your numbers are going to be slightly different. Let's do it. All right. So here what we have, I'm going to do the bottom part first on here, and then I will do the top part next. Okay. Notice line 2. What kind of line is this since it's just y equals? It's a horizontal line, right? So if we want to find the equation of a line parallel to it, won't a line that's parallel to a horizontal line also be horizontal? And we just went through the equation of any horizontal line is y equals whatever the y value is. Does that make sense? Now, in this next part, we want to find the equation of a line perpendicular to this. Again, if this is a horizontal line, what type of line is perpendicular to it? A vertical line. And we just saw the equation of any vertical line is x equals whatever the x value is. You with me there? Again, this is making sure you understand that when you see y equals with no x mentioned, you've got a horizontal line. And then linking what the equation of a horizontal line is, and then realizing that anything that's parallel or perpendicular to a horizontal line is vertical, and knowing what your vertical is. Okay, I can also do this first part. I'm going to write it on my separate sheet of paper. And we want parallel through -6, -6, and then perpendicular through those values. All right, I'm going to stop sharing my screen. Chocho, does that answer your question?
Yes, thank you very much. Yes.
Oh, okay, cool, cool. So I am going to just quickly do this because we have 4 minutes, and so we might as well make great use of our time. Okay, if we want to find the equation of a line parallel to this, what do we know about the slope of this line that we're going to find? It's the same, it's -4. So thus far, we've got y equals -4x plus b. I need to find my value of b. How do I do that? I plug in this ordered pair. So I say -6 is -4 times -6 plus b. I love when they give us ordered pairs that have the same values, because then you don't have to worry about bebopping your x's and your y's. So we get -6 is 24 plus b. We'll subtract 24 from both sides to get b to be 30. So in this case, -30, excuse me. We're going to get -4x minus 30. How about the perpendicular line? If the slope of this guy is -4, what's the slope of the line that I'm looking for? +1/4. Remember, you change the sign and you flip it. So thus far, we have y equals 1/4 x plus b. And again, in order to find b, we plug in the ordered pair that we're given. Well, I don't care whether you put it in decimal form or fraction form. I'm kind of a fraction type of person, but some people don't like dealing with fractions. You could literally put 1/4 times -6. Okay. But you're going to get -3/2 or -1.5 plus b. And then we would add 3/2 to both sides to find b. Does anyone want me to take this to completion using fractions, or are you all going to want to use decimals anyhow? Decimals. Anyone want to see it with fractions? You're like, no. Oh, someone said yes. Okay. Oh, Autumn, I'm happy to see you. Okay. So if you're cool with decimals, essentially what you're doing is just taking -6 and adding on 1.5. Okay. If you want to see this with fractions, this is what we're computing. We need a common denominator. Well, in order to get our denominator of 2, we got to take this first guy and multiply it by 2/2. So we have -12/2 plus 3/2 is -9/2. Wasn't that cute? Okay. Well, my friends, again, I got 1 minute just to do a recap. Check your email. Like, that's the long and short of it all. The video for lesson 14 and the notes for lesson 14 are in the box folder. I have direct links to each of those things in the email I sent to you. So that replaces class on Friday. We do have class next Monday and Tuesday, you know, barring unforeseen circumstances like, you know, I get in a car crash or some such thing on the road. Well, you never know. I'll be here Monday and Tuesday to teach you. If you're here in Missoula in person, cool. If you want to Zoom in from home, it could be a family affair and they could all join the math class. Kind of joking. And of course, I'll be recording them anyway. We do have off next week, or you do have off next week, next Wednesday, Thursday, and Friday for the Thanksgiving weekend. And if anybody doesn't have a place to go over Thanksgiving, I do know that the UC is holding a Thanksgiving meal for people who are here. I would say you're welcome to drive down to my place, but you're not going to have a typical Thanksgiving dinner. Bean burritos, my friends. So that's what we do. Anyhow, I'll see you next week. Thanks, everyone. I appreciate all of you.